So the task that we were asked to complete was to find the shortest route between Hamilton and Tapao. So I've shown you one technique, which was finding the shortest arc from the currently activated node, and we came up with a value of 213 kilometres so far. So now we need to see, maybe use another method to see if that is definitely the shortest route and if we can find a short one. So the next thing I do is probably a tree method, and what I've done to make it easy for you to see what's going on, I've actually cut the map out and put it here so that then you can see me create the tree. I can create so many routes because it's not Dijkstra, so it doesn't kind of keep track. It takes a lot of work and it kind of ends up being a massive expanse of a diagram. So I'm going to show you how to start it, and then I'm going to show you how to do a baseline assessment, pick one route that looks relatively short but isn't necessarily the shortest route possible. So then you cut out some of the work, because you can use that baseline route to compare. As soon as you get to a number that's larger than that baseline on your tree diagram, you can just cross that route through and stop. You don't have to go all the way down to your final point because it's already larger than you need it to be. So I'm going to try my best to show you, and we'll go now. I'll just move that out of the way. So I'm going to keep this in the corner so you can see what I'm doing. So my first place I'm going to start is Hamilton, so I'm going to put Hamilton at the top. Now from Hamilton I can travel three different, 1, 2, 3, 4, because it's an odd, even node. So I'm going to do 4 rather spread out tree branches. And on those I can go to Parongia. Okay, I can also go to Waimutu, and I can go to Cambridge. Now the trick to these is writing small and spreading out so you don't end up with all your ideas and all of your workings crunched up. Now I'd say that probably the easiest thing to do is to put the names of where you're going at the bottom of each branch, and then actually label them with the distance on the actual branch. So the first one was 32. The next one was 29, the next one was 23, and the next one was 68. So I would use different colours to help it stand out. So now if I went from from Hamilton to Matamata, I can travel down 2 different arcs. So I'm going to just put this over to this side. So again, we're trying to keep it really spread out. And that takes me from Matamata to Tirau. Okay, sorry. And from Matamata to Cambridge. And what this is really checking is it quicker to go straight to Cambridge, or sometimes it's quicker to actually go via a different village or a different town. So we'll see if that's the case. So here already we've got 68 to go to Matamata, and then from that 68 we would have to travel 41 to Cambridge. So that's a lot more than just going straight to Cambridge would be. So now to Tirau we would travel 21. Now I'm not keeping a running total at the moment. What I'm going to do is add it up as I go later on. I'm going to have a different colour to keep a running total. I'm going to do that at the end. I'll show you why. So I won't, when I do it next time, I won't do it as I'm at the end, but I'm just keeping it simple for the minute. Once I take a baseline, then I'm going to keep a running total, so I'm constantly comparing it to the information I've already got. So now from Tirau I can go to Cambridge. I'm not going to go that way. I'm going to cross that one off. Oh, sorry, excuse me, Cambridge, because I began on myself, so that's what I use. And I'm going to do Tirau, and I'm just going to shorten things now. So because already I'm running out of space, and this is why using baseline later on will be super important. So to Cambridge was 52, to Tirau 61, and this was 32. So I'm going to cross off this one, and why that is because I'd be going back on myself, and that's not helpful. And already to get to Cambridge could be reached really shortly in 23 kilometres. I didn't need to go via Matamata, then Tirau, then to Cambridge. So that is not a useful route. So I'm just going to cross it through, and I'm not going to continue that anymore. So already the examiner can see that I'm not choosing this route because it's a waste. It's a waste of my time. It takes too long. So now from where are we going? From Tokoroa, I'm getting there. We could travel straight to Tapao, and that would be, that would be 66. So now I've got to the end of Tapao, I can add this up. So let me just grab a calculator. Somebody's taken my calculator. So I can add those up. So I've got 68 plus 21 plus 32 plus 66. So that is 187. So that's actually quite large. Or was it? Matter. That seems quite large. So let's see. It might be the smallest, but I don't think it is. And then from Tokoroa, we could also go to Tikuti, and that would be 114. Now already there's no point going down this road because 114 is already bigger, and to get to Tapau, you would need to do 113 here. So again, we can cross this route through. It's too large. So I can just stop. If you wanted to be really clear to the examiner, you could add it up and just show that it's larger. So for instance, you could do 68 plus 21 plus 32 plus 114, and that's 235. But I've crossed it because I know that 235 is greater than 187. So that explains to the examiner why I stopped there. I haven't carried on. Great stuff. Okay, so where am I now? So if I went back down this road, right, I would have gone from Hamilton to Matamata, I would have gone to Tirau, and then from Tirau I could now go to Tiawamutu, and from Tiawamutu I could either go 70 or 48. So I'll put those two down. So that's 70 or 48. So this is a problem. Be really clear. My writing's a bit scruffy, but you want to make sure that it's really obvious to the person looking at it that this route isn't actually Tapau. So 48 will take me to 2, and this one was to Tokoroa. So now, from Tikuti, I would travel 113 to go to Tapau, and from Tikotu, I would travel 66 to get to Tapau. So there, I have both my stop points. So I can add them up as I go to check what I get. So let's add them up. We travel 68, then we travel 21, then we travel 61, then we travel 48, and then we travel 113. So that's 311, which is greater than 187 so far. So I know that I'm going to cross that one through. I wouldn't use that route. So let's try the other one. Now the great thing about a Cassia calculator is you can delete back to where you went down a different route. So we did the 1, 2, 3 trails the same, and then at Tiawamutu, we then branched out. So instead of travelling down this route, we went this route. So now I can cancel back and type in 70 and then plus 66, and that gave me 286. So 286. Again, 286 is greater than my 187, so I can stop. So let's cross it through. So going down this end at the moment, my shortest route so far is actually going to be 187. So what I was saying about baseline is, what you could do is just find a route that you think looks pretty small and use that as your baseline. So for instance, if I'd just eyed in a route and said, right, 235 is going to be my baseline, I could have written that route down, and then every time I got to, as I added it up as I went, as soon as I got to 235, I could cross it out. So I'm going to use a baseline of 235, and I would explain to the examiner how I got there. No, I shouldn't have picked 235. I shouldn't have picked that for a baseline, is because I haven't actually got to the end. That one I stopped with. I'm really sorry about that. So I'm going to use this one. So 286, we did actually get to the end. So that one, I went from Hamilton to Matamata to Tirau and then to Toko, and then from Toko I got to Tapau. So straight away the examiner can see, that's my work, can see that if I get to a number that's bigger than 286, I'm adding up to stop. Yes, that's kind of baseline. It stops me having to work out any numbers that are bigger than that. So it cuts down a lot of my workload. So let's go back to this. And we've gone down all the possible routes from Tirau. So now let's try Cambridge. So from Cambridge, I've got, it's going to be a bit of a squidge, but we'll do our best. So from Cambridge, I wouldn't go back to Hamilton, so I don't need to bother to do that route. I wouldn't go back to Matamata, so I've actually got 2 routes that would be useful. So 1, 2. I've not left myself a space, but we'll see how it goes. So that's going to be to Puturu, and then this one, which was from Cambridge, it was 32 to get there. From Tirau, oh, donut, sorry. And let's highlight that so I don't forget. And then Cambridge to Tirau is going to be 24. So now, from Tirau, I can only do one junction. I can only draw one arc or bridge, and that would be 32, and that would take me straight to Tokoro. From Tokoro, I would go back on myself to do 114. Oh, I would not go back on myself to 114, and then do 113 when I could just travel 66 this way. So I'm just going to go straight from there to Tapau, which is 66. Oh, come on. So that's 66. Okay, is it okay? So now we can have this route up as we go. So I started with 68, then I went 41 to Cambridge, then I went 32 to Tirau, then I went another, have I missed one? Yeah, I did. And then it's okay because I did, so I went from Hamilton to Matamata, then to Cambridge, then I went to Tirau, and then I went another 32 to Tokoroa, and then I'm going to travel 66, and that gives me 239. So, oops, wrong pen. So 239 is greater than 187, so I wouldn't use this route. Now I'm going to show you why using the baseline makes your life easier. So let's do this route so far. So I'm going to keep a running total of each number. So if I went down this route, I'd do 68 to Matamata, then plus 41. So far I have 109 here. Then I would add another 24, which is 133. Now, this 133 is still smaller than 286, so I would keep going. So when I get to Tiawamutu, which is here, I could do 2. One would be to Toko, and the other one would be to Titi. Okay. And this T, and this one is T. So far I've got 133 here, so I'm going to add another here, which gives me 181, and that's still not as big as this one, so I'm going to keep going, and I'm going to go back and delete this one, so that gives me 251. So this one's getting pretty big, pretty quick, so I'm going to be really careful that I don't go over this now. So 251 would get me to here, but then another 66 would be too big, so I'm going to stop, because, hang on, that would be 66, and adding 66 to that would give me 317, and 317 is bigger than my 286, so I'd stop. So notice here, I used, when I was using 187, that was the smallest. That was just because I happened to find a relatively smallest route, so I used it to compare the others, because I found a short route early on. Whereas this one, on this route, I've tried to show you different methods, so ignore this section. I've picked a baseline. I just found a random route that I thought was kind of a relatively sensible size, not too big, not too small, so I can use that to compare. So here, I did manage to get all the way to the end, and my number was pretty similar to 286, so I kept on going to the very end so I could compare it, and I realised that the route that I found was actually bigger, so I just cancelled it and crossed it through, just so that I'm not going to use it. Whereas this one is quite small still, so if I go to Takuti, I've got 2 possible routes. I've got going to Tokoro, which I haven't been to, Tokoroa, wrong colour, and then Tapau. So Tapau, I would have been adding 66, wrong colour again, 66, and I need to add that up. I've got 81 here so far. That's why keeping a, that's called a cumulative total, because you're accumulating the values as you're going along. So 181 plus 66 equals 247. 247. So that one so far is looking pretty good because it's not, so that's a possible. We're not sure yet, it might actually be smaller. Unfortunately though, it's not actually the smallest because we've got this one here that we used a different method earlier, but they both work and they're both logical. Okay, so now I went to Toko, which is 114. red pen again, 114, and now I'm going to do 181 plus 114, which is 295. Now this is why the baseline is really helpful. So I know that I have 295 here, and I know that 295 is bigger than my baseline that I already have, so I can cross it off without having to go all the way to my final destination. It cuts out. So as you can see, this is a super time-consuming method, and that's because this is kind of super helpful. But I think if you showed that you've done this and you've showed logical methods, and so for instance, I've done this section, but I showed the examiner that I do understand how to use the method, I just maybe haven't done it for the entire tree. I'm going to stop here in the middle. I hope from this you can understand what's going on and adapt it to your use. I'm going to say for the time being that 187 is the shortest route I've found so far. And I make my definite decision, I'm just going to definitely add it. Right. So we did 68 plus 21 plus 32 plus 66 and 187. So I think that's the shortest route so far. And I know that this one, 247, is bigger than 187, so I'm going to cancel it. So I'm going with that shortest route. Now notice that our last shortest route that we found was 213. So actually, this method was less effective than this method so far, so we can write about that in our analysis and explain to the examiner that we understand that actually in this situation, this method wasn't effective as this method.